In section 8.3, we're going to talk about rotations. On page 515 in your textbook, look at the gray region in the center where it says essential understanding. Put a star next to this. Rotations preserve distance, angle measures, and orientation of figures. What that means is if you take a shape and rotate it, the shape is going to be congruent to the original image. So now we're going to look at the key concept, rotation about a point. You have to understand that rotation is not as easy as it sounds. You know rotating means to spin something. But it's going to depend on what you're rotating it around based on what you're actually going to do with the problem. So in this key concept, we're talking about rotation around a point. It says, a rotation of x degrees about a point Q, called the center of rotation, is a transformation with these two properties. The image of Q is itself. That is, Q prime equals Q. It's going to be the same point. For any other point, V, QV prime is going to equal QV. So that means the distance from Q to V prime is going to be equal to Q to V. And the angle, the measure of the angle, VQV prime, that represents your x, how many degrees you're rotating it. So look at the shape that's given to you. The darker shape, triangle UVW, has been rotated up x degrees, and you can see in the picture what the x degrees is, about point Q. That means point Q doesn't change. It's like you put your pencil on point Q and then spin it around that point. That's called the center of rotation. Q and Q prime are the same point. And then the rotation gives you the image U prime, V prime, W prime. So it says the number of degrees a figure rotates is the angle of rotation. A rotation about a point is a rigid motion. You write the x degree rotation of triangle UVW about point Q as R, meaning rotation, and then in parentheses, x degrees about point Q. So if you look at the parentheses, the first number represents how many degrees you're moving it, and Q is the point that you're rotating it around. Unless stated otherwise, rotations in this book are always going to be counterclockwise. In question 1, on page 516, it says, draw the image of each figure for the given rotation about point P. Use prime notation to label the vertices of the image. So here's where it gets, this is going to be not the easiest thing. I'm going to start with A. A is right here, this line. So you actually have to use a protractor, and you have to move it 60 degrees. It says we're going to rotate this 60 degrees. Counterclockwise is always this way, because it's the opposite of a clock. So you actually have to use a protractor and measure 60 degrees. So I'm actually doing this right now, so you might hear the protractor on the iPad. So on the iPad, it looks like 60 degrees is going to be about right here. So I'm marking it. This is me marking it on my iPad. So then 60 degrees would be right here, and that's going to be called A prime. Now remember, this distance, P to A and P to A prime have to be the exact same thing. So you have to use a measurement and measure to make sure it's the same distance. So then my next point, I'm going to move D. So if I move D, I'm going to use blue here. So if I move D, I'm going to measure this. D is approximately 1.5 inches from P, and I have to move it 60 degrees. And 60 degrees is going to be about right here. And it's going to be about 1.5 inches. And 1.5 inches is about right here. Whoops. And that's going to be D prime. Now I have to do B. And B, I'm going to make yellow. And this measurement is approximately, it's about 1.5 inches as well. 60 degrees. And obviously you are going to have an accurate measurement because it's harder to do this on an iPad than on paper. So 60 degrees is about right there. And 1.5 inches is about right here. So this would be B prime. So the image, triangle A prime, B prime, D prime, should be congruent to your original shape. This takes a little bit of practicing. It takes a little bit of getting used to because it's not the easiest thing. You have to take the time to draw an accurate picture. So this would be rotating 60 degrees. Now if you wrote this down, it would be R, 60 degrees, about point P of triangle ABD. All right, now on page 517, it says at the top, when a figure is rotated 90 degrees, 180 degrees, 270 degrees, or 360 degrees about the origin in a coordinate plane, you can use the following rules. Key concept. Here's your key concept. If you rotate it 90 degrees, your point xy is going to become negative yx. You can take the time and use a protractor, or you can basically flip the order pairs around and the first one becomes negative. So, for example, 2, 3 in that picture becomes negative 3, 2. If you rotate it 180 degrees, you just take the x and y and make them both negative. If you rotate it 270 degrees around the origin, xy becomes y negative x. And if you rotate it a full 360, it's going to become the exact same thing. 2, 3 becomes 2, 3. So let's do the got it problem. In the got it problem, we're going to rotate quadrilateral FGHI 270 degrees around the origin. Now reminder, you're going to go counterclockwise. So I'm going to write the image in red. So we're going to start with F. If we look at our key concept, it says that 270 degrees means I'm going to flip them around, your x and y, and then the second number becomes negative. So if I flipped F, negative 3, 2, I flip them around, that's 2, negative 3, and then the second one flips the sign, so it'd be 2, 3. So it would become 2, 3, and that would be F prime. Now, point G, negative 3, negative 1, I flip them around. It'd be negative 1, negative 3. The second one flips the sign. So it'd be negative 1, 3. And negative 1, 3. Becomes G prime. H is negative 1, negative 1. I flip them. The second one changes signs, so it'd be negative 1, 1. So that'd be H prime and the last one, which is point I, is 0, 1. Flip it, that's 1, 0. The second one changes, well, it's still going to be 1, 0. And that would be your shape. If you actually took it and moved your paper 270 degrees, that's exactly what it would look like. So let's do the practice problem number 3 on page 518. In exercises 3 and 4, we're going to use the graph at the right. Now, I'm not going to regraph it because it's right in your book that you can use and write with. So number 3. So we want to rotate quadrilateral FGHJ 90 degrees around the origin. So if we look at the graph to the right, I've already written the order pairs for each of these points off to the left of this graph, so it's easier to look at. So if you look at your key concept, 90 degrees, rotation of 90 degrees, that means we take XY, and XY becomes negative YX. So we flip them around and the first one becomes negative. Or basically is the opposite of the first one. So F, that's going to become F prime, and that's going to become 3, 0, and then we change the sign opposite, so it'd be negative 3, 0. So negative 3, 0 is F prime. G, that means G prime, is going to become 1, negative 4. And then we have to take the opposite of the first one. So that becomes negative 1, negative 4. Negative 1, negative 4. That would be G prime. H is 1, negative 4. We flip them. That becomes negative 4, 1. But then the negative 4 becomes positive 4. We have to do the opposite. So that'd be 4, 1. That's H prime. J prime is 3, negative 2. So we flip it. 2, 3. Take the opposite of the first one. So it'd be negative 2, positive 3. We connect them. And there's your quadrilateral. If you actually took your book and turned it 90 degrees counterclockwise, it would look just like this shape. Let's now look ahead at the last problem on page 518, where it says using properties of rotations. Here is the problem 3 on page 518. So you can just write this in the got it section. In the diagram, WXYZ is a parallelogram. And T is the midpoint of the diagonals. How can you use the properties of rotation to show that the lengths of the opposite sides of the parallelograms are equal? Now in the diagram, it's going to show you this. This side becomes this side, and this side becomes that. I'm not going to give you the answer on this video. What I want you to do is think about it by yourself. Think about the properties, what this property of rotation tells you. How can you use the properties of rotation to show that the lengths of the opposite sides are equal? So you have to use the properties to show the opposite sides. For example, if we're doing opposite sides, that means WX would have to equal YZ, and WZ would have to equal YX. So prove to me that these two sides, opposite sides, are equal. We'll be going over this in class, but I want you to really take 5 minutes and think about how you do that.